Hello everyone, welcome to today's session. So I'll be handing it over to Mr. Dinesh. He's our presenter today. Please, Dinesh, you can continue.
Yeah, thank you so much for that. So, yeah, this is Dinesh here. So, today's session is about how can mastering data science increases your career opportunities. So, data science is a vast domain, as you all know. And what are the different career opportunities that are available in data science? And also, what are the different applications of data science? That is what we want to understand in various domains. So, if you see, there are a lot of domains where data science is getting used, and the domain knowledge is spanned across all these different industries and organizations. And in different ways and forms, data science and analytics is applied across those verticals, and there are a lot of use cases that have came up similarly. So we want to understand all of them so that we can cater the opportunities, and also we can find a way to grab them. So that is what today's session is about. Before starting the session, I want to introduce about myself. So if anyone have attended the last session, so you would have already would have known about me. So yeah, so this is Amara Dinesh here. So currently I'm working in a firm in research and development, as a AI researcher. I have a total experience of 6 years in machine learning, data science, deep learning, and reinforcement learning. So I have already published good amount of books and contributed good research papers in reputed conferences and journals. So yeah, that's about myself. I have also done my masters also with a major in EA. You can find my research papers here, and you can also access the code I have written here in my GitHub profile. So yeah. So if you see, there's a lot of hype around the data science and machine learning and deep learning, particularly AI. So all these different technologies I was speaking of yeah, comes under a superset of AI. So yeah. So there's a lot of news that comes across, and when they are accusing across different sites, we are going to see all this fancy news that they come across, right? So if you see, this is a daydream algorithm from Google. So what it does is it is going to transform. You see, you have this image here, and this particular image is transformed into this. So you have a style. So this is a painting. So we are using this style. Whatever the algorithm that we have trained is using this style and transforming this image into something similar to this. So we are making art form of the present picture that we have taken from a particular view. So for doing that, there is something called a generative adversarial network, which is an unsupervised learning way of training the things. We are using that, and we are performing this neural style transfer. So yeah, so that's what it's technically called. So yeah, so you can see there are a lot of fascinating applications that we come across using data science and machine learning and deep learning. So where is the data coming from? So what is the need for data science, and suddenly why we have a sudden demand and soaring for data scientists? Because if you see how many smartphones we are using, and how many sensors that we are deploying across, and now if you see the CCTV footages and CC cameras itself, you can understand how many are deployed across a particular city, and across a country. If you take country wide, how much monitoring is going on, and how much data it is generating. So every second it will generate say 30 frames per second. So it is generating 30 frames of data, and it is doing it across the days. So understand how many terabytes and petabytes of data is generated only by some set of monitoring cameras. And if you can imagine for the complete country, it's unimaginable, right? How much data we are going to generate. and how we are going to store and process this data, and how we are going to analyze this data and finally get some insights from the data. That is what the main challenge is. And if you see, most of the data is unstructured. So image data or video data is generally unstructured, and you have this natural language data and speech data, which we generally speak of to understand that. It's not very much structured, so it's also very much unstructured data. So there's a lot of data that we are generating, and we are recording that particular data also. And we have to finally get some insights or do some sort of predictive analytics on top of that, right? Then only there's some value for the data that we are recording and whatever the storing or processing we are doing. So yeah, and then coming to the devices part also, if you see, we have this advent of Internet of Things, and also along with that, we have this internet enabled devices in our pockets, which are your mobiles and tablets and different devices with different form factors. So we have this 50 billion plus devices and 6.1 billion smartphones, and you can see like how much data we are generating using all those different platforms that we are using, by connecting to internet and using Facebook and other YouTube and Twitter. So there are a lot of applications that we are doing, and there's a lot of interaction that's happening. So there's a lot of messages that we are sending, and there's a lot of website visits and the clicks that we are doing. So everything is recorded and everything is analyzed. So to leverage some value. So we see the use cases, then you'll understand what is the benefit or what is the profit that we are going to obtain by doing that. So yeah, so but you have to just convince yourself that there's a lot of data that we are generating, and we have to find some way to understand and analyze it. So yeah. So yeah, so once you have a data, so you have data with you, and you have an action that you have to perform, and for performing that particular action, you have a decision, right? So you have to take the decision for doing that. So suppose if you have say you have some thermostat or thermal actuator. Suppose temperature has to maintain 30 degrees centigrade is the temperature, constant temperature that has to be maintained in a particular room. Then what is going to happen? It's going to monitor that. There's a thermal sensor which will monitor the temperature in the room. Suppose if it is less, suppose it is 20 degrees, then it will decrease the air conditioning, and it will try to make it 30 degrees. So there's a control algorithm that applies there, or there's a decision automation that takes place there. And suppose if it is 40, then air conditioner is again sort of like comes into picture, and it tries to reduce the temperature or get it to 30 degrees centigrade, which is your set temperature. So yeah, so here if you see, you have the data with you. So to sensor, you want the data, and then you have to perform some set of action by taking a particular decision to increase or decrease. So yeah, so that's called decision automation. That's the reason I have given you this example so that you can understand. So yeah, so there's a prescription and there's a recommendation, and there's a decision automation. Recommendation is it is recommending you because of like there's something that is going to happen, or there's something that you prefer. So there's a recommendation that is given to you. If you're browsing Netflix, there are some like movie recommendations that you will get based on your browsing history. So if you take it or not, it's your wish, but based on your preferences, algorithm is recommending. So that's what a recommendation system is. And prediction is nothing but if you want to predict the price of the stock, closing price of the stock, by analyzing the data of past 1 year. So you have some Tata Motors, you have a stock, and you want to predict the closing price of the particular stock today. So you have the past information of 2 or 3 years. So you will analyze the closing price of all those years, and using some data science algorithm, you're going to make a prediction out of them. So, yeah. So there are a lot of things that can be done by analyzing this particular data using the data science mechanism and algorithms that we develop. And yeah, so if you see data science, obviously data scientists are the whole domain, and there's a lot of hype that's going on. So it's a hard job. That's the reason. So that's the reason I was explaining you all the sort of things to convince you that there's a lot of requirement that is going across, and obviously there's a demand also that has came up. And yeah, as I was explaining you regarding the data generation
Dinesh,
process. So,
Dinesh,
hello.
sorry to interrupt, Dinesh, but actually we are getting some kind of disturbances in after you speaking. So I don't know if
Yeah,
something.
just give me a minute. What I'll do is, yeah, now it should be fine.
Yeah, yeah, it's fine. It's fine. Yes.
Yeah, yes. So, yeah, let me continue. Sorry for that. So, yeah. So coming to the big data part, so whatever the data that we are generating, there's a huge amount of data, right? So for handling that, there's a separate set of tools and architectures that have came across. So it comes under big data. So there are four ways of big data, which is very basic one, and whoever are aware of big data, it's a bread and butter of them. So this four are nothing but you have the volume. Volume is nothing but the scale of data. So the amount of data that we are talking of, it is in zettabytes and petabytes, terabytes. So the volume of the data and the variety of the data and the veracity of the data. Veracity in the sense what is the uncertainty in the data, and the velocity of the data. So velocity is nothing but how fast the data is coming, and you see the sensors. Now, if you have an automobile and you have some sensors, so there are a lot of sensors embedded into it, and if it has some autonomous features, then there are a lot of processing that is done in the embedded chipset that is present, where it has to take a lot of real-time decisions. Yeah, so it's about streaming data. So you are getting data on the go, and you have to process that and give your predictions on the go in real time. So that is one more separate subject where there are a lot of optimizations that will go on into the algorithms, and there are a lot of constraints that your algorithm has to susceptible of, and there are a lot of considerations that you have to keep when designing algorithms or whatever the data science related um, code that you are going to run in those kind of environments. Yeah. And yeah, so there's availability also. So if you see some 5 to 10 years back, there you don't have sufficient computing power to handle this kind of big data, and also you don't have the frameworks that you can use of, like you don't have the graphical processing units or parallelizing capability or handling or the tools that are required for handling these kind of data. But if you see now, you have all this. So even if you see the computing power also, so obviously computing power according to Moore's law, computing power is going to increase or double every 2 years, right? So the number of transistors that you can keep on a particular chipset. In the something similar to that, so you have the price that is going to decrease, or for the same price, you are going to get a good amount of computing power. So you have a lot of computing power that is available, and you have a lot of storage that is available, or cheaper storage that's available, and you have the algorithms also, and you have the frameworks and architectures for processing that, and you have the algorithms also finally to perform the analytics part. So everything came together, and we are in a very good shape now to perform or to use this all the technologies to build use cases and solve some interesting problems. So yeah, so these are the different distributed frameworks. Hadoop is the popular one. Most of the people may have, you guys should know that. And Apache Spark is the latest one. And then you have a lot of deep learning frameworks and machine learning related frameworks that are available, which we are going to use. Yeah. And then, as I was explaining you regarding the hardware part, so if you see hardware, so I just want to give you a basic understanding, which will be helpful for you. So it may not be the direct application, but it's a sort of like footnote for you, which you, as you guys are data scientists or inspired to become that. So I want to tell you that if you see the hardware part itself, suppose if you want to parallelize your algorithm, or if you want to write your code, your data science algorithm, or you want to write some sort of code which generally will perform the training and testing passes. So most of the time that you are going to take will go in the training part itself, if you are aware of. In training, what happens is you are going to optimize something. So you are trying to decrease your cost function or the loss function, there is an optimization algorithm which iteratively performs a training procedure and tries to fit the data, or try to train your model. So for doing that, if you parallelize it, so if you see CPU or a computer processing unit, what it does is serial processing. But if you take GPUs, graphical processing units, they have the advantage of processing the data parallelly. But for doing that, there are a lot of conditions that are there. So coming to the conditions part, one thing is, suppose you have your desktop or laptop with you, and you want to train or parallelize a particular algorithm. For doing that, yeah, you have it, and in your first condition is that you should have the physical hardware that is available. So you should have a GPU, preferably NVIDIA GPU. So assume that you have an NVIDIA GPU of 4 GB or 2 GB or 4 GB. So you have the GPU with you, and once you have the GPU, so it should have a driver, so a compatible supported driver that has to be installed. And once that is done, then there is something called CUDA. CUDA is nothing but it's a language, and if you write it in C or C++, if you write it in your general code, then you cannot parallelize that. Why? Because GPU has to understand that, right? So GPU has its own language of itself, which is called CUDA. So if you want to do any parallelization, you have to write it in CUDA language. Then only hardware understands and parallelize whatever the operations that you are mentioning. So you have to install your CUDA software, and then there is something called CUDNN. So yeah, you can see it, right. So the CUDNN is nothing but whatever the deep neural networks are there. There are some set of operations like mathmul and multiplications and some set of things which can be parallelized. And for doing that, you need this CUDNN package. So so you have to install CUDNN also. And finally, you should have a TensorFlow GPU, a PyTorch GPU supporting application. So there are two things. If you go to TensorFlow website, you have something called TensorFlow CPU and TensorFlow GPU. So you have to download the TensorFlow GPU, and then you have to run your code. And there's no explicit mentioning that's required. So there's an option like GPU one. If you just keep it in configuration file, which is defaultly done, then it whatever the code it can be optimized, or what are the operations it can optimize, it will do it automatically. Now what happens, so if you have performed some multiplication operation, so two tensors are there and you are doing a tensor multiplication, then you have a GPU supported TensorFlow, and it is sending you the operation across, and you have the CUDNN which converts or which takes it, and then it talks with the CUDA, and CUDA talks with the device driver, and device driver internally talks with the GPU, and perform the parallelization, and finally it collects the output, and the operation is performed parallelly. So you have to make sure that all these things are working properly and interface it together in a proper manner, so that you can do parallelized training. Why I am telling this, because it may be out of context, but I am telling this because there's a lot of misconception that is there across many people. So they'll feel that they are training their algorithms in a GPU, or they are feeling that they are parallelizing it, but most of the time the parallelization is not going on. So and they would be wondering why algorithm is taking this much time for training. So you have to make sure that all these things are in place, so that your real parallelization is going on. Okay. Yeah, so anywhere, anybody have any doubts, you can ask me. So feel free to do that, or you can ping the same in the chat box also. So anything is fine with me. So please interrupt me wherever you feel disconnected or you want further explanation or any queries or questions. Anything is fine. So if you see the roles, there are a lot of roles that are available in the data science itself. So if you see the general sort of like the data science pyramid. So you have the data sources, and there you are doing the data pre-processing, and then you will do the data exploration or the exploratory data analysis, which is the visualization part. And then you have the modeling and algorithms where your machine learning comes into picture. And finally, you are presenting your results, and based on the client or the higher authority or management, they are going to take a decision. So it's a decision making part. So yeah, so if you see, this is a pyramid, and if you see all this complete pyramid is dealt with the data scientists. So a data scientists do all those things, and if you see a data engineer, the difference between a data scientist and data engineer is data scientists can build the algorithms and perform the data wrangling and everything, but he cannot scale the operations or make a operable pipeline in for an enterprise or for application. So you need a pipeline that is built across, right, or a platform that is required. So yeah, and also maintenance and operations and the updations for the machine learning models, data integration and the databases. So there are a lot of things that has to be considered or taken into consideration, and all those things are done by data engineering. And then you have a visualization expert who will create some nice looking dashboards. So there is something called this D3JS and 3JS and other very good plotly. So there are a lot of visualization and dashboard applications and softwares which the visualization expert will take on. So yeah, so these are different roles that are required in the data science project. And then yeah, so coming to the skill set part, there are a lot of skills. So you cannot directly tell that data science is only this. So there are a lot of different domains and the different streams that data science scientists should be aware of. So it's a combination or amalgamation of different skills which you can see there. So yeah, you have a bit of domain knowledge, and you should need understanding of the machine learning and data mining, statistics part. So there are a lot of things, visualization, code, and computing part. And then yeah, if you see, you'll see this thing, whatever the data science pipeline I was referring to. You would have a good idea of it. By this time. Why? Because I was explaining you the same, right? So how you are going to take the data and you are going to clean the data, and then what is the training and testing part that you're going to perform, and once the model is built across, how you are going to deploy the model. So yeah, so there's a lot of depth and lot of work that is required for every step that we are discussing of. But let's take it briefly. Why? Because it needs a separate session and separate understanding for doing that. So ours is more of related to application, right? So I'm just giving you overview of that. And yeah, why choose data science as a career? So if you see, data science is spread across these different industries, right? If you can just see how many industries there are. So you have agriculture, you have finance, you have pharma, you have automotive, healthcare, manufacturing, telecom, whatnot. So you have a lot of industries where data science is applied across. Obviously, it turns out that you have a lot of opportunities also, right, in different organizations and different companies. And then there are different use cases. So if you see the agriculture itself, there are a lot of interesting use cases that are present. So even I was trying to do something. So how we can predict or recommend a particular crop. So recommending the crop is the first part. Taking into consideration what is the month and what is the place, what is the latitude and longitude of the farm of the farmer, and based on the precipitation and based on the humidity and so if you have a lot of sensors and you have all this different data that is available, by taking into consideration all this data, we can give a meaningful prediction or recommendation to the farmer. And once you have done that, then you can he'll start the farming part. And once he do that, then even in the diagnosis part also, we can help him, right? So it is sort of like he has a mobile and he'll take picture of the plants and if you have fruits or vegetables, he's going to take a picture of that. And by analyzing the picture, we are going to tell the health of the health of it. So is it has any what is the health of that, and what are the different again you have this pesticide recommendation that you can do, right? So what are the different pesticides that you can use for that particular if you have a bug in that, so how you can kill that. And if you have pests on the leaf, or there's a deficiency in the leaf or the plant, so how you are going to mitigate that. So what are the fertilizers and pesticides that you have to use, and what is the quantity of that. So that information also we can tell to the farmer. And then is the ripening stage has came or not. So in the similar way, so if you can visualize, or if you have a image of the plant, by seeing that you can tell the by based on the texture and color, and there are some features that are available using which you can tell is it the right time for harvesting. So in the harvesting time also we can do the recommendation, right? So this is the right date or right time for harvesting the crop. So yeah, so I'm just giving you a use case of agriculture. So in the same way, there are lots and lots of different use cases that you can come across. We'll see some of them. So yeah, so if you see healthcare, IBM Watson is providing diagnosing procedure for cancer. So for classifying the tumors as malignant and benign, we are using data science and machine learning algorithms. So yeah, so instead of doctor doing all the things, we are assisting the doctor by using the data science and machine learning algorithms. It is not that we are going to, or we are trying to replace the doctors itself, but we are going to assist them. So whatever the diagnosis part is there, we want to automate the diagnosis part using data science. And then there's a concept of the smart cities. So you take the smart cities itself, there are a lot of sensors that are deployed across. So you have all these different technologies that are coming together. So if you take a smart city, most of the smart city concept is has an intersection with Internet of Things. So if you speak of Internet of Things, it is related to sensors. So again, if you take sensors, again there's a complete platform that is built across, and most of the part, if you want to do sensor data analytics and streaming data analytics, so there is a lot of analytics that has to be performed. Why? Because obviously the sensors are generating data, so you have to make sense of that particular data, right? So so everywhere you should have data science platform in place to perform the analytics part. So this is one more use case. Yeah, so if you see, there's also this Amazon's AI-driven virtual assistant Alexa. So if you see Alexa, if you are aware of, there are something called this Google Home and Alexa. and you have Apple Siri and Microsoft Cortana. So these are assistants, voice enabled assistants. So you can speak with them, and they will understand your language, and based on that, they are going to speak to you, or they are going to perform some set of action. So if you want to ask Amazon Alexa to play some music, it will do that for you. So you can just play music and it will play that. So it is going to understand that whatever you told, and then it is going to perform an action accordingly. So yeah, so what they are trying to do is they asked it which city buses are running late. So you can ask the Alexa platform itself, are the city buses running a little late, or how much time they'll be running late. So where the bus is. So there are a lot of things that can be done. So if you make use of this data science and machine learning in an optimized manner, and identify some interesting use cases, then there are a lot of advantages and lot of value that we can leverage across. And there's something called this web analytics. So web analytics is nothing but, as I was discussing previously, you have something called this click rate, right? So there are a lot of things that are monitored across in the web, whatever the things we are doing, like the hits that we are doing, or the pages that we are viewing, or the session duration. And so there are a lot of things in the background that are going to run. So when you are visiting a web page, and what are the ads that you're clicking, or what are the pages that you're viewing, and how much time you're spending. So everything is monitored in the background, so that they can understand it, and based on that they can recommend you something, or they are going to make some sort of some sort of personalized caterings for you. So yeah, so once they perform the analytics, they can act accordingly, and at least they get an idea of what's going on. So that is what the concept of dashboards is, right? So if you see this example dashboard, you can see you have a website, and how many sessions are there, total sessions, and total visitors, and the new visitors, and the total time spent. So there are a lot of things, right? If you can see, so it's a Countly dashboard. So there are some very good visualizations that you can come across. And then yeah, you have something called this collaborative filtering. Collaborative filtering is nothing but it's something similar to recommendations, but you are going to take the opinions of a lot of people, or group of people, and based on that you're going to receive your recommendations part. That is what collaborative filtering is. So you are getting the recommendations based on the collaborative filtering. So you can see that. So all these things are under the hood when you're browsing some website, or when you're opening your Amazon and Flipkart. All these things are going on. Only thing is we are not aware of that. So if you understand, and if you do it next time, then obviously you'll connect, and you'll know that how the system is going to do it, or how underneath the algorithms are working upon. And then yeah, so in LinkedIn also, when you go there, and when you go to your network part, you can see there are some predictions. So people who you may know. So again, there is something called this graph analytics, where you can identify the relationships, and automatically the suggestions are provided to you. And if you see, healthcare is a very vast industry, and there are different domains in the healthcare also. So it's a very huge domain. And there are a lot of use cases. There are a number of use cases when it comes to data science in healthcare. So yeah, so you have this electronic medical records, EMR records, and there's a lot of clinical data that has to be stored, and that has to be understood. Which if you want to convert these traditional medical records into electronic medical records, and then you have to store them, and then you have to perform analytics on top of that. So that is one clinical data, and you have the patient behavior, and you have the sentiment data, and you have pharmaceutical and R&D related data. You have the claims and cost related data, which comes under the hospital organization, or the hospital finance part. And then you have the hospital recommendation part, and how the hospital monitoring part. And also hospitality, or how the hospital is chosen, or what is the rating of that, or what is the review of that. So all these things can be understood and analyzed. So yeah, so you have this real-time alerting part which I'll discuss, and you have this predictive analytics in the sense by seeing the body mass index or height, weight, and some set of different criterias, you're going to be the predicted, or you'll get a prior insight into the risk that you are going to face. In future. So are you going to have a heart attack or diabetes, or what is the risk of that? So you can predict that. So yeah, so that is predictive analytics. And you have the telemedicine part where you have some remote clinical services. So yeah, so there are a lot of things in healthcare. So it's just a glimpse of that, so it's a huge one. And then there is something called this predictive maintenance, where if you see the electric grids, or if you see nuclear reactors, and there are a lot of places where these SCADA or control related systems are very critical. So they are safety critical systems, and they are obviously very dangerous, right? If they are not operated in a proper way, or if they are operating above the threshold. So for predicting those catastrophic things, and performing the activation or preventing that. Yeah, so we can use data science for doing that. And yeah, so for operational challenges or understanding about the problems, so it's a use case of a manhole. So yeah, so there's a lot of predictions that you can see here. So yeah. And then what are the sectors data science is used across? So I have already told you and showed you the same. But if you see, you have manufacturing, you have transportation, retail, science and technology, IT and communications. You have education. So education in the sense coming to the monitoring of the children, and how you're going to deliver the lectures. So and then how you're going to grade the students, and how you're going to provide the learning resources, or personalize the recommendations of learning resources. So there are a lot of different places where AI or data science is used in education also. And then healthcare we have discussed, energy is there, and construction and agriculture that we have discussed. So there are a lot of different sectors where you're using them. And yeah, if you see, you have similar thing what we are discussing of. So along with that, if you see here, you have all these electronic and connected devices, and internet of things related stuff. So all these things are again generate constant data. So wherever a sensor is there, there's data that you're going to receive, and there's some sort of processing that we have to do. And after doing that, there may be any prediction, or there may be any recommendation, or any decision that you're going to take, or actuation. So all the things depend accordingly. And then you have sports. So in sports also, data science used. Nowadays, everybody are using in all the different sports. Data science is getting used. So in cricket or football, so how to analyze the opponent moves, and if you see in cricket, how the bowler is bowling, and how the where he is bowling. So what are the short pitch deliveries, or what is the type of bowling attack he's preferring, and what are his weak areas, or if you take the batsman, so what is his strength of it, or how exactly he's reacting, or how he's playing well. Is he handling spin well, or is playing good in fast bowling? If so, is it left arm bowling or right arm bowling? So there are a lot of analytics that can be done, and a lot of insights that can be gained. So generally, these coaches nowadays, if you watch the sports frequently, you'll observe that somewhere you will see this dashboard where they will be monitoring and seeing all these things. So yeah, so there are a lot of applications there. And in banking and finance, will speak. So a lot of use cases that are coming across in banking and finance. So you have blockchain and cryptocurrency, where data science is also getting used in some way. And you have the payments and money transfers. And then you have the insurance domain. It's again a different vast domain. And you have this equity and crowdfunding, and you have the investment management. So yeah, so obviously banking and finance is a very broad domain, right? Huge domain. So there are a lot of applications. So in internet search also, if you search something, obviously you are going to get the results, right? So you have a sorted order, and based on the priority and preference, you are going to see the results. So for performing all this, there are a lot of prediction algorithms that are running under the. And then you have digital advertisement part. If you see traditional advertisements, they are moving or shifting across to digital platforms. And if you see, a lot of advertisements are have become digital. So yeah, so coming to the social media platforms, there are a lot of ads that are coming now. And also in different websites also, if you browse for, so a lot of them are surviving using this AdWords or AdSense or digital ads. So there also, whatever the click rate that we are discussing, right? So the number of clicks that the user is going to make, or where he's going to click, or which product he is liking more. So a lot of analytics, that is which ad has to be shown to the user so that the conversion is maximum. So instead of doing this blind advertising, you are doing a targeted advertising by using or leveraging the data science. And then you have this recommendation system, as we were discussing. So in YouTube we'll get recommendations, and in Netflix or Amazon Prime, so anywhere you go you have this Amazon. So anywhere you go you have always these recommendations that you are going to get based on your past browsing history. So, and you have image processing. So if you see, it comes under deep learning and computer vision particularly. If you have a car, or you need some algorithms which will identify what is the object. So this is object detection. So you have car here, and this is a bicycle, and this is a person. So everything is detected and localized recording. And yeah, speech recognition has become an integral part, right? So again, there are a lot of applications in speech itself. So you have to understand the speech. So there is translation, transliteration, and there are again a number of use cases and applications that are spanned across the speech. And the gaming part, so that's the Kinect. If you see, you're going to take the Kinect data, and going to analyze that, and replicate it, or whatever the actions that you're going to do, you're going to simulate it in the gaming platform. And price comparison sites, and yeah, it is route planning. So you have to find the optimized route to reach the destination in a comfortable, preferred way. And you have the fraud and risk detection. So again, it comes under the security part, and there are a lot of things. So you have a lot of case studies. So one is credit card default prediction, and you have the loan sanctioning, or the loan default. So should a particular person be granted loan or not? So that is one use case. And transaction risk management. So if you see transactions, is it a fraudulent transaction or not? And spam classification, is it spam or not spam? So yeah, a lot of case studies and use cases that we can discuss of. And then we have the delivery logistics, and Internet of Things, as I was explaining you and told you that it's very vast, right? So yeah, so we have the healthcare. So if you see this, you can see the tumor classification, and based on the tumors and based on some set of features, how we are going to classify or identify particular person has a particular disease or not. So we are performing the diagnosis. We are not performing the diagnosis or any recommendation part, but we are going to perform the classification or identification of it. So if he has a disease or not, with this particular accuracy, with this particular percentage. So we are going to tell all the confidence score. So with that, we are going to tell that. And then the self-driving cars, where we have where we are seeing, right, you have this image processing. In the same way, a lot of things are there under the hood. And robotics. So Yeah, so the advantages of data science in the present society, how we are going to get benefited, or the society is going to get benefited overall by leveraging the data science. So there's a lot of energy saving that can be done by using the smart devices I was just now referring to, right? So if you have some smart devices where automatically they can switch off. So there are some bugs that you can see now, right? So if anybody steps in or comes across, the light will switch on. If it is not, then the light will automatically get switched off. So it has become smart. So by doing that, it is saving a lot of electricity. So and power. So a lot of energy is saved. So everywhere there's optimization that can be done using these data sets. So you're doing a monitoring or doing some recommendation or some action, and finally saving the power, electricity, or energy, whatever the resource, which is very precious for us, right? So that's a very good thing. And you have this data-driven hospitals that we were referring to, right? So if you have some set of hospitals, right from the patient entering into the hospital and then he is leaving from the hospital, complete thing can be made data-driven. So the electrical records, whatever the electronic patient recording system, right? So all the reports of the user or the patient can be digitalized, and then they'll be stored digitally, and then predictions or analytics is applied, and remote monitoring is also done now. And there are some set of devices like Fitbit, and there are some trackers that are coming. So you can wear that fitness band or fitness tracker, and then you are going to get how many steps that you have taken, and how much fat that you can burn in particular number of days or particular day. So there's a lot of analytics that is coming across, and even if you sleep also, there's a sleep monitoring system that is in place. There's a sensor which can tell you the number of hours you have slept. And again, there also we can see some nice visualizations, like how many hours in a day or across a month on average you are sleeping. So again, there's a lot of data-driven techniques that are there, and by decreasing the usage of power or energy, in turn we are making our environment or our planet more greener and cleaner, right? So well, yeah, so in turn, so by optimizing the processes and also saving some valuable things like power, energy, indirectly we are making our planet greener also by using the data science related algorithms and techniques. So yeah, so I have planned for covering some more set of things, but as we are short of time, I'm done with the things. So I just want to give you overview of what are the different sectors and different industries and verticals data science is spanned across. So hope you got some idea of how the data science use cases are framed across different industries. I have given you some sort of examples so that you can connect, but there are many, and even the data science is also a very huge domain. So it is not confined to a particular industry. So each and everywhere you can where you can think of, you can apply data science. Wherever there's data, I'll have to perform some analytics on that, and have to apply these algorithms across. So it's very complicated thing, but I have tried to do my best to give you some insights on that. Hope you have understood the session and got some insights into it, and based on your interest you can dig deeper, and you can understand about the things in your own way, and you can explore further. You can take it as a starting point, and you can choose a particular domain which you are interested in. So what I would suggest you is you can start exploring the things, and then try to understand. If you're a fresher, try to understand these domains, and choose a particular domain, and then get into that. Or if you are an experienced person, then in data science, domain expertise is very important. So what you can do is you can gain the domain expertise, and or if you already have it, suppose you have some 10 years experience in as a financial analyst, so already you know the domain and you know about the complete subject. Now you can map it to the data science. Whatever the tools or techniques available in data science, you can map it. So that will be it will be a huge advantage for you. Why? Because obviously I know data science, but I don't know have the domain knowledge, right? So you have worked in that particular domain for 10 years, but I have not. I don't have the domain knowledge, and even if I try to do that, it will be very difficult for me to catch up in the short. So yeah, so all these are the different advantages that you have, and then you can enter into or you can choose a particular domain and try to see the use cases pertaining to that particular domain. And what we can do using data science, or what are the things that we can analyze by using the data science tools and techniques. So all these things you can think of. So yeah, so that's it from my side. So a lot of things are there that we can discuss, but hope if we have some further sessions extended, we can do the same. Okay. Any queries or questions or anything? I'm open for that.
Thank you so much, Dinesh. That was a really great session. Students, if you want to ask some doubts to Dinesh, you can write in the chat box. It should be below of your GoToWebinar dashboard, or you could also raise your hand and I can unmute you so that you can ask your question. Dinesh, I don't think there is no student has any doubts or questions regarding this. So we'll just, end the session right now. Thank you everyone for joining, and thanks Dinesh again for this wonderful session.